Welcome to the fifth lesson in Session 7 on problem solving. We start with percent problems. Whenever a price is changed, you can find the percent of increase or decrease by using the following formula. Percent of change over 100 is equal to the change in price over the original price. So percent over 100 is equal to the change over the original. The change in price is the absolute value of the difference between the original price and the new price. Identifying the change in price. If the original price of a car is $10,000 and is now on sale for $8,999, find the change in price. So what we do is we just use subtraction. So 10,000 minus, or 10,000 minus 8,099. We're going to take the absolute value of that, so that's $1,001. So the change in price in this case would be $1,001. The original price of apartment is $600 per month. It now costs $650. Find the change in price. So 600 minus 650 is negative 50, but its absolute value is going to be $50. So it's always a positive number. We subtract the two values, and we have the change in price. So here we have a couple of examples. In the first one, the real estate taxes of the house next door went from $1,560 to $1,638. What was the percent of increase? So we have to start by identifying all the important information. The original price of our real estate taxes was $1,560. The percent of change is unknown, so we identify that as X. And the change in price we identify from subtracting 1638 minus 1560, and that leaves us with 78. Now we just need to plug these values into our formula. We end up with X over 100 is equal to 78 over 1560. Since we have a proportion, we can solve by finding the cross product, which is 1560x equal to 7800, and when we divide by 1560 to isolate x, we're left with 5. So the real estate taxes increased by 5%. In the next example, the number of registered voters in Franklin County increased by 14% over the last year. Last year, there were 8,450 registered voters. How many voters are there this year? Again, we need to identify all the important information. My original number of voters was 8,450. My percent of change was 14%. And my change in voters comes from identifying how many new voters there are minus how many voters there were the year before. Since I don't know how many voters there are this year, I represent the change as X minus 8450. And I substitute that into the formula, which gives me 14 over 100 equals X minus 8450 over 8450. Again, we have our proportion, so we can identify the cross product to help us solve, which gives us 100x minus 845,000. That's equal to 118,300. Add 845,000 and divide by 100, and I get x equal to 9,633. So a 14% increase produced 9,633 voters this year in Franklin County. Next we go with work rate problems. Work rate problems help us to identify how much work an individual completes in a given job. We're going to use the following formula to solve work rate problems. R times T is equal to W, where R represents the work rate, T represents the time, and W represents the amount of work that was accomplished. And the work rate represents the fractional part of a job given in a single unit of time. It's represented by the amount of work an individual will complete in 1 hour, or 1 minute, or 1 day, depending on the unit of measure that's being used. So here's a few examples to help us understand work rate. If Sherry can rake the lawn in 2 hours, her work rate is represented on how much of that job she'll get done in 1 hour. And that will be represented as 1/2. So if it takes her 2 hours to do the job, her work rate's going to 1/2. Teresa can paint the room in 4 hours, her work rate is going to be 1/4. Because she'll get 1/4 of that job done in 1 hour. If Frank can build a shed in 3.5 hours, what's his work rate? Well, you see in the first two examples, which holds true, we use reciprocal values. So we take the reciprocal of however long it took for the job to get accomplished. 2 hours is a work rate of 1/2. 4 hours is a work rate of 1/4. So if it's 3.5 hours, we have to represent that as 7/2, and then we take the reciprocal. So the work rate in this case would be 2/7. For our example, Josh can paint a fence in 4 hours. His father can paint the same fence in 2 hours. How long will it take them if they work together? To help organize, we use a table. So Josh has a work rate of 1/4. Father has a work rate of 1/2. They're going to be working together for the same amount of time, so we assign T as that unit of measure. And we'll multiply straight across to represent the amount of work done, and Josh does x/4 of the job, while his dad does x/2. To set up the equation, we take the sum of the amount of work that each individual completed and set it equal to 1. The 1 represents the amount of jobs that were completed. So they did one job. They painted one fence. That's where the 1 comes from. Josh did T/4 of the work. His dad did T/2 of the work. And now we solve. We now multiply the entire equation by the least common denominator, which in this case would be 4. And that's going to give us T plus 2T equals 4. So T is equal to 4/3. We now have to express this answer in reasonable terms, so it would take Josh and his father 1 hour and 20 minutes to paint the fence. That wraps up our lesson and our session, so good luck on the quiz and the test. Please email us if you have any questions.